Hello, everyone. Welcome to the next episode of the Radio Data podcast. Today, our expert guest is Kevin Goldsmith, who works as a CTO at Anaconda. Kevin, welcome to our show.
Thank you. I'm very pleased to be here.
Yes, that's fantastic. And as always, let's start with the introduction. So, could you please let us know more about yourself?
Absolutely. I am the Chief Technology Officer at Anaconda. If you are unfamiliar with us, we're primarily known for making an open source distribution of Python that's really focused on data scientists and data practitioners. It's used today by over 30 million people. And we've been doing that for 10 years now. We have other products as well, but we're also kind of some of the core maintainers of kind of well-known packages like Numba, like Dask, a lot of other kind of core data science projects we're involved with, Jupyter notebooks, things like that. And prior to Anaconda, I've been a CTO at companies like Onfido, where we did data science for identity verification using computer vision and deep learning. And at Avvo, where we were a legal marketplace, and we used a lot of data science to connect and help people with their legal problems. And where you and I met, I was a VP of engineering at Spotify for a number of years. I was responsible for what was called the consumer engineering group. Essentially, we were the ones who made the product, the mobile and desktop and web clients, as well as ingestion and doing all those pieces. Before that, I was at Adobe for a long time, as a Microsoft for a while, or a long time, and other companies as well.
Yes, so in my opinion, it's very impressive work experience, and I will definitely ask some questions about the companies that you have been working at. But maybe let's first focus on Anaconda, because you work as a CTO there. So could you please describe us how your daily work looks like at Anaconda and what your responsibilities are?
Sure. So we do, beyond having obviously we come from open source. We are an open source company at heart, but of course we're also a commercial enterprise and have to make money to pay everybody's paychecks and things like that. So it's kind of split. So a big chunk of the organization is really focused on building the Anaconda distribution, and it's a lot of problems that you would maybe not expect. Building Python packages at scale is actually really hard, especially because a lot of the core data science Python packages are not written in Python. They're written in C, they're written in C++, they're written in Fortran, actually, quite a lot. One of my favorite jokes that I made, if you don't mind, is that the D in data science for Python stands for Fortran, because they're just the amount of time we spend, because all these old packages were built on top of existing science packages. So when you talk about SciPy or AstroPy or any of those, especially kind of more niche-y kind of data science realm, there's a lot of that stuff. So a lot of my time, a lot of the organization's focused on that. Additionally, we have commercial products, primarily enterprise-based, that I have to do normal kind of B2B type CTO stuff around meeting with customers, making sure product development's on track. We have something called Anaconda Nucleus, which is more aimed at practitioners, helping them do their jobs, and that's something that has been growing a lot. One of the things I came to the company to help do. So it's just kind of normal CTO stuff, which is meeting with customers, working with the executive team, helping make sure the technology organization's doing what's needed for our customers. It's not a specifically like data job more than any others, sadly, even though we are so focused on data science as a company.
And can you also explain why do data scientists and various companies choose to use Anaconda? And what are the most important reasons?
There's a few reasons I think that specifically. One is because the distribution's been around for a number of years. When I was first getting interested in understanding data science more, which was many years ago now, I was a software developer. I come from a software development background, and I was certainly familiar with data, but I wasn't really. I was now working with data scientists. I was getting interested in using it, and so I bought a book from O'Reilly, and like chapter one, install Anaconda. Anaconda is actually, honestly, how I learned Python, because I was more of a C++ developer before that. And so that is how a lot of people join, because when Anaconda came out, it was one of the only ways. I mean, it was really hard to install Python on Windows, nearly impossible. Anaconda made that problem easy. Now it is much easier to get Python on Windows. However, the Anaconda solver called Conda, different. If you're familiar with Python, you're familiar with pip install, whatever pip upgrade. So we have Conda. Conda is very similar to pip, except that there was a lot of effort put into the solver. So the pip installer, by the very nature of the way the PI works, the package, the packaging authority, they would have anybody upload binaries, right? They don't build all the binaries for Python. People upload the binaries. We build them. So we build them to make sure they're compatible with each other. But also, we are very good at figuring out incompatibilities between packages. So it's very easy with pip to install incompatible packages and break your environment, and everything stops working and you don't know why, and you spend a lot of time doing that. One of the reasons why data scientists like Conda is because Conda won't let you install incompatible packages for the most part. You can still mess up your environment, but it's way harder. And because of that, you spend a lot less time kind of debugging your environment and just more time kind of focused on the work. And data scientists generally don't want to spend lots of time figuring out their environment. They just want to do their work. And for that reason, it's stayed very popular. It's another reason why universities, when they teach data science or numerical computing at all, they generally have their students install Anaconda, because it installs all the kind of base packages you need, as well as it stops them having to spend a lot of their time fixing students' environments. So that's why people use the Anaconda distribution.
Yes, many good reasons. Thanks for answering this question. And now I would like to switch topic a little bit because before our podcast, I did a small research about Anaconda, and I checked on your company website that it says that today around 30 million users from over 200 countries and regions use Anaconda. So this is a very big scale, and I'm sure that you know a lot about use cases and success stories of how different people and different companies use Anaconda and Python to analyze this data. But in this particular podcast episode, I'm very much interested in how Anaconda uses own data and own internal analytics to develop own product. So would you be able to share some information about this?
Yeah. Yes.
So, for example, like what data sets you take into account when you analyze how Anaconda is used, or what data you use to decide which features you should implement next in your product. So, simply speaking, how data and internal analytics are used at Anaconda.
So we have an incredibly valuable data set that is unique to the company, which is package installations, right? So when you Conda install, when you Conda upgrade, we know what packages you're updating. We know what packages you're installing. That's our sort of really kind of interesting data set, because 30 million people around the world use it. Unlike, because we are sort of an open source kind of at heart, today we actually don't know very much um, about the individual because we don't record any information. So there's not telemetry in the Conda installer because that would be a little creepy. And so we actually don't. We want to maintain the trust of our users. However, we are trying to figure out how to use that data in more practical ways. In the simplest way, we know what packages people are installing, and once you get past the sort of NumPy, matplotlibs of the world, it actually gets really interesting to see what sets of packages are installed together. That gives us a lot of information around what new things are coming into favor. And one of the things that I've worked on at the company since I've joined a couple of years ago has been actually taking advantage of that. Could we know the next stable diffusion before it happens? Right, before everybody knows about it, just by watching what packages people are installing in aggregate, because that's really the data we have. So we as a company, our data store is evolving. I have to be careful how I say it, because honestly, what's fascinated me joining the company, given that it is a data science company, is we actually did very little data science in the company. We're a company that built tools for data scientists that a lot of people who work at the company are former data scientists, now software developers. But we did very little data science ourselves on using our own data. And that's been a lot of the evolution of the last couple of years. And that's a lot of, that'll be a lot of evolution in the company for the next few years. We're really only just getting started around that and using it to make better product decisions. So if I'm going to be honest, like, yeah, we're evolving ourselves. So I'm using a lot of what I've learned at prior companies to get us set up and to actually get a reasonable data infrastructure in place. We would, unsurprisingly, in a company that had a lot of data scientists but not a lot of ML ops people, until recently, a lot of stuff was still running on individual people's laptops and stuff like that, or running on, in our case, we have a product called Enterprise Edition that lets you spin up environments. Yeah, there's a lot of stuff running on private instances of things like that. And we've been moving that all onto a data infrastructure with scheduling, with real time, with an actual data warehouse. And yeah, but we're still relatively early in our life cycle as a company.
And you mentioned that we both work at Spotify at the same time. And as you know, at Spotify we had a number of dashboards that I believe that everyone at the company was looking at regularly, even each day. For example, a dashboard with the number of monthly active users globally or per country. And do you also have some particular dashboards or key metrics that you look at every day as a CTO at Anaconda?
Because we have these very different, in a lot of ways, Anaconda is interesting also as a relatively small company. Um, as a relatively small company, the number of products we have and the different audiences we address, because we have a large, a large part of our business is enterprise using our tools, enterprise using our products. And then we have the open source pieces. So it's not one dashboard. At Spotify, there was a set of metrics I looked at every day, sometimes many times in a day, because the areas I was responsible for were primarily around retention. And so I was watching all the metrics from all the squads that led up into retention, and I was watching retention daily, and I was looking at all the experiments we had running on a daily basis, but it was all around that sort of single product, right? There's differences between the iOS client and the Android client, but they were all kind of leading to the same thing. For us, I'm really looking at I'm looking at CVEs against our packages. I'm looking at package flow. How quickly are we, when somebody updates a package, how quickly are we turning it around? I'm looking at delivery to our customers. We have partnerships with Snowflake. We have partnerships with Microsoft. We have partnerships with Amazon. We have partnerships with IBM, Intel. Like, are we, I'm looking at that and how we're performing against our agreements with them. I'm looking at AnacondaCloud, and that's a little bit more of a traditional B2C SaaS platform. So there I'm looking very much at those kind of, activation, retention, those kind of normal product metrics. I'm looking to see if anything is interesting about package downloads, right? So we've found issues where uh, national laboratories or something we're copying our entire package repository every hour for no particular reason. I think somebody out there just decided, oh, we want to keep our own local copy, and wrote a bad script. So I don't think it was a deliberate
Yeah.
decision. I think somebody just messed up, and then we had to reach out to that lab and tell them, hey, I don't know if
Mhm.
you realize this. This is probably not good. But I'm looking for those kinds of things, spikes and those normal things. But it's against a whole bunch of different products that each products or areas that each have kind of their own metrics I look at. But absolutely every day.
Yes, so looking at this data, for example, product metrics or package downloads, helps you to make many data-driven decisions about how your product or even products should be developed and in which directions they should go. And when I asked these questions first time, I intentionally focused on your internal data. But I'm sure that you also take into account some external data sets. So, for example, do you also take into account some specific data points in the global market or in the data science community to decide how Anaconda should evolve?
Yeah. One thing you see from us, so every year we publish something called the State of Data Science. It's a report that we generate every year. And we get that from talking to people. It's a lot of it's survey driven. A lot of what I've been trying to do is get it more and more data driven. But we are constantly looking at what's going on in the world, what new companies are bringing in new things. A lot of my focus has been around ML ops and making that easier for data scientists. So we track the open source and see what kind of interesting projects are coming up and being adopted. We look at specific kind of ML and AI technologies, and a lot of it is driven. To be fair, a lot of it's driven just by talking to data scientists, which we do all the time, or following blogs. A lot of that kind of stuff shows up before I'd see it in like a dashboard. But one of the things I have been working on is trying to get that to be a lot more data driven, watching the feeds, watching Twitter, and trying to see if we can identify some of these things a little bit faster. But to be honest, given how connected we are as individuals, we tend to surface things. We still mostly surface things through individuals seeing something and then sharing it internally and kind of raising it. And we have a pretty good network that way.
So, you told that there are still many things that you can do at Anaconda. And what is the end vision of the platform that your company would like to build? And what is the ultimate goal that you would like to achieve, let's say, in 5 or 10 years?
One of the things that was really interesting to me joining the company, and obviously I was familiar with it before I joined, was just how central it is to so many data engineers, so many data scientists, so many numerical computing people's jobs and work, and finding out how much it underlies. Even anacondas in all these places you don't know because you don't see it, but you can say, any almost, but way more than you'd imagine, machine learning or ML ops or anything around this product that you're using probably has an Anaconda underneath it. It's probably built on top of Anaconda, which honestly, I didn't even know until I joined the company and started meeting with our partners and realizing, oh wow, okay, I didn't know that was built on top of Anaconda. We want to continue to be kind of good, independent stewards. I think one of the reasons why people feel very comfortable with us is we are very much of the open source. We very much care about the open source community. We very much feel part of the open source community. Um, and we help make that accessible to people. And it's very clear that open source is going to be the thing that continues to drive innovation in AI, in ML, in data engineering for as far as we can tell, ever. So the vision is, how do we make that easier for people to use, more accessible for people to use? How do we make folks who do this for a living, how do we make their daily lives better?
Mhm.
And that includes both contributing on the open source side. As I said, like a significant chunk of my team is working on open source projects full time, right? um, and will continue. And Anaconda was one of the places that incubated. We didn't create Jupyter Notebooks, but we helped incubate the project at the beginning, and then kind of were involved, and then stopped being involved in the last year with the change from Notebook 6 to Notebook 7 really being a completely different platform. We got re-involved and are now kind of the primary contributors on the Notebook 6 tree, because we were concerned that people who use notebooks every day, Jupyter Notebooks, which huge, millions of people do, that there are especially things like professors and stuff who teach with it and use all these plugins. Those plugins all break in Jupyter Notebook 7. And so we wanted to make sure that we were going to help those folks, but then also help bridge them to the new platform, because we care about the daily lives of practitioners. And so you'll see us continue to develop new open source projects. You'll see us contribute on critical open source projects that we think are important to the community and we want to support. You'll see us continue to come up with new tools, commercial or open source and commercial. We didn't talk about PyScript. PyScript is something we launched this year, very exciting. Essentially um, builds on top of WASM, builds on top of other Python in the browser projects to essentially create a easy to Python script in the browser. That's incredibly helpful for things like data visualization, is incredibly helpful for kind of lightweight data processing. Right now, there's some really cool projects that have been done, like doing, Jupyter Lite and things like that. Very still heavyweight, very slow. We're working on making that accessible, but also giving Python, giving developers tools, and especially numerical computing tools in the browser, so you don't have to do a bunch of stuff on your desktop or go to cloud all the time. So it's about making data practitioners' lives easier.
Yes, it's a very exciting and a very bold mission.
No point in going small.
Exactly. So helping every single practitioner and every single company to use Python and data science more efficiently is great. And yeah, I keep fingers crossed for achieving this goal. And so far, we have been only talking about Anaconda, what was extremely interesting. And I'm sure that I will be able to ask more questions about your company. But still, we have some time left. So maybe we can switch topic to a data science in general. And I prepared a few questions for you for this section of our conversation. And I will start with the trends in the data science. So, would you be able to tell what, in your opinion, are the most important trends in the data science that you currently see?
There's a few things that I think are really kind of interesting that I personally have been focused a lot on. I don't know whether I would call this kind of the generalized trends, but this is the kind of thing that I've been focusing on just because of my role. So one has been an interesting rise in security around machine learning and AI, because for a long time we kind of ignored it, and because we could. And I think one of the things that again, because of my prior role where I was doing more machine learning around fraud prevention, the interesting thing was seeing, so we were building machine learning models to identify fraud, and what we saw was the folks intending to commit fraud were building machine learning models to attack our machine learning models. So because the tools that we have access to, right, the tools you have, the tools I have, everybody has access to those tools, including the people trying to commit fraud, and also the ambient level of knowledge around data science is growing, which means more people understand this. So if you were building models, let's not even say you're thinking about fraud. Let's just say you're trying to make decisions around granting loans. Well, I guess that is a bit of fraud, but you're making critical decisions using machine learning models, or even human in the loop models. If there's ways that folks can take advantage of those, you have to assume they're using tools as sophisticated as yours, and that they understand how your tools are made. So they are doing things like people are posting models on Hugging Face or on Kaggle or those kind of places. Hey, check out this model for doing this NLP thing. And what you don't realize is that model works, but it was trained on data that is opening a backdoor so that they can throw data at you that is going to influence the decision process. It's not going to be obvious, even if you have good drift detection and things like that. So security around AI and ML is really kind of, people are growing an awareness of it. Not enough, but it is people are starting to become more aware of it. I think we are getting better, but we're not great yet on machine, especially if you're using deep learning and some of those techniques. No one understands how the models work, and getting better visualization, getting better comprehension of the models themselves is becoming more important over the last few years, and especially for things like bias detection and things like that, is, I think, a really interesting area that has had more investment and needs more. That's another area that I've been really focused on, is bias detection in models and in training data. PII, especially as we add more privacy laws, especially as we get into things like having to be careful about folks attacking to get PII. Training models, being able to train models um, on non PII data, or finding ways to abstract PII data that still makes the models trainable. Just saw a new paper on this the other day. That's interesting. That's another security and privacy. These are some of the things that I've been most focused on. But at the same time, this other thing that I mentioned is also really cool. The fact that you have platforms like Hugging Face, you have a lot of these platforms existed, but the accessibility of this stuff is just so much more helpful, or so much more there, which means that you don't quite need a PhD in statistics anymore to actually be a practicing data scientist. Doesn't hurt, but that's, I think, really interesting as well, is those tools, unsophisticated versions of those tools are becoming more accessible, which means companies are able to take advantage of them without having to build a data science team. But I also think it's really cool in that none of those tools is going to get you all the way. And the more sophisticated your company is around data, the more you realize, oh, actually, we need to do this ourselves, because no one tool will solve all your problems. So that used to be where an enterprise would have to, a CEO or somebody in the execs team would have to make a decision. I've heard this data is important. We should maybe hire a person to do that. And then that person would get frustrated for years trying to convince everybody that they needed to use data better. And eventually maybe they'd win and get to build a small department and grow up. Now I think companies all understand, no, we need to do it. They also understand they can get started on their own, get some value reach the limit of the tools that are kind of broadly useful, and then they need people like you or people like me to kind of come in and help them really evolve once they've already understood the value. And that's been increasing. So accessibility of the tools just continuing to grow. Sophistication of the tools, oh my goodness. I keep thinking about Stable Diffusion as an example, just because it kind of, this is cool, the thing that OpenAI did, or I don't even remember if they were the first, but they certainly popularized it. Oh, this is a cool technique. And it's sort of, normally a few years ago, somebody'd have a paper, like MIT would do a paper, or Google or whatever, and everybody read about it and go, oh, that's cool. And maybe over time, folks would figure it out and start to kind of make its way around. This thing went from, hey, this is a cool thing, it does this stuff pretty well, to here's 1,000 different implementations of it, and here's how you install it on your Mac at home. That's amazing. Like, this time from cool new technique to mass adoption, I've never, like, PyTorch didn't do this. Like even open source projects, right? Nothing has gone this fast, and I'm fascinated to see if this becomes a pattern for other new techniques that just move the state of the platforms just faster. So yeah.
Yeah, absolutely. I agree. And when you were responding to this question, I also started thinking about the trend that I see in general in the big data landscape. To some extent, this might be also related to data science. What I see is that we have more and more technologies that use SQL as a main data processing language. For example, we have Snowflake or Flink SQL or dbt. And this also lowers the barrier of entry to do analytics and possibly data science.
Yep.
And how would you compare like SQL to Python? Because like Python is the language that you use at Anaconda, but on the other hand, SQL can be also used to do data science. And do you see those languages as maybe competitors, or maybe they complement each other? Maybe like the data scientist should know them both to actually be efficient in his or her daily work?
At a prior company, there was maybe in my team, there's maybe 10 analysts that just wrote SQL all day, and then a few data scientists, some writing Python, some writing R. And no, they work together very fine. I think this is not a new thing. SQL has been, in a lot of ways, the lingua franca of data analysis forever, because it is extremely accessible, even from kind of non-programmers. So a lot of finance people I've worked with, they know SQL. They know enough SQL to do some fairly sophisticated things. It's a surprisingly, like, having learned SQL right a long time ago, it's a surprisingly accessible language. I never would have thought about it that way, but people have learned it and learned enough to do good stuff with it. I don't think that competes with Python at all. And I think, we're partners with Snowflake. So one of the things we've done at Anaconda is they have this Snowpark thing where they let you write extended queries in JavaScript or now Python, and including, like, you can do, most of the packages we have are available, and you can write those in your queries and stuff, and just to give that kind of escape hatch for much more sophisticated type of processing. I think these things will continue. I don't think they compete. I think they coexist. I think that a lot of what we're doing is trying to make things more accessible to folks who are not kind of programmers, make it easier for them to do more sophisticated things, whether that's PyScript or something like that, that is easier for people to use. We will continue to do that. So no, I think very much anybody who's doing this will know, or at least understand, SQL. And if there's ways that they can start to learn Python to do more sophisticated things when they reach the limit, right? It's this is 1,000-line SQL query, or I could do this in 5 lines of Python. They'll learn. I think as we make things more accessible, as we make them easier to learn, I think that'll be an obvious way for folks to grow. So no, I think they're very much complementary. There's a lot of stuff I still do in my own work because, of course, our EDWs and Snowflake. Yeah, I'll write queries. I could write Python. I'll write query because I can do that faster and some stuff. And then there's places where it's just easier for me to write Python. It's faster for me to write Python. So yeah, the right tool for the right job.
Yeah, that's true. And we have still a few minutes left, and I will have a final question for you. This is also related to the trends, data science, but in short term. The final question is about the job market. And this year, we hear very often about layoffs in the tech sector. And how, in your opinion, data science and data scientists as a job sector are resilient to such layoffs comparing to other roles in the tech industry?
I can't speak to layoffs specifically because I don't know. I don't have enough knowledge on like who's getting laid off from Twitter and who's getting laid off from other places. But I can speak to hiring in the market because I'm hiring. I would imagine in these big companies, it is impacting the data teams as well. However, as somebody who's been hiring data scientists, data engineers in this market, it's a very healthy market for job seekers. One of the things that's also been great for folks who are in this area is, again, because so many companies are now fully remote or partially remote or whatever, is that we've had to do that. And I don't mean we Anaconda, I mean we, the industry, have had to do that because it was so hard to find people, right? Prior companies, it took forever to hire a data scientist because there was so much demand for them. So me being able to hire in Europe or being able to hire in different parts of the US or Canada or wherever has made it easier, but these roles are still very much in demand. These are still one of the hardest roles to hire. It's a little bit easier for us because we're at Anaconda because we're well known by data scientists. At prior companies, it was a struggle, but it's still difficult for us. There's still a lot of demand for these roles. Even as the economy does whatever it's going to do and whatever is going to happen in the industry over the next couple of years, I don't see the demand for these roles getting smaller. I only see them getting bigger. As I said, it's great that the tools, easy versions of the tools, are now accessible. All that's teaching companies is companies who never would have thought about having a data science team or data scientist are now getting enough knowledge around how valuable it is that they're going to want to hire at some point. They will reach the limit of what they can get off the shelf and they will want to hire. So yeah, I'm not there's some roles that are always going to be hiring, and I think data science, data engineering, data analysts, these are roles that will be valuable for a very long time. We're not reaching a saturation of that market at all.
Yeah, so this is also the observation that I make, that the data, cloud, and analytics sectors are very healthy and very resilient, and there is still a very high adoption of data-oriented and data-specific solutions. And when I analyze the data about the layoffs and read articles describing them, then it's very often mentioned that other departments are more affected, such as sales, marketing, recruitment, HR, what of course makes me sad that people are losing their jobs. However, the data says that those layoffs don't impact data engineering roles that much. And also, even recently, I saw some article saying that only a few % of data engineers, if any, are laid off by their companies. But also, it's worth adding that usually such engineers quickly find jobs in other companies because they are recruiting. So in the worst scenario for data engineers, it can happen that maybe they need to change their jobs, or maybe they need to do something to upskill themselves, but usually the impact is not that high, especially comparing to other roles and people working in other departments.
That's absolutely right. Yeah.
And yeah, so this was my final question. And I would like to ask if there is anything that you would like to summarize or add before we conclude our podcast.
How about I ask you a question?
Yes, please.
One question I have for you, Adam. Before you and I started recording early, we were just catching up, and you were talking to me about some of the work your company has been doing. And we talked about bringing agile processes and agile frameworks into data engineering, into data science. And I've found it, I have been able to do it, but I've found it really challenging to get teams and companies, especially understanding that this is an area you can use agile practices in. What have you learned from working with different companies about that?
Yes, sure. So first of all, we have an internal process called getting data way of working that we follow when we start new projects. And probably the most important goal for us is that we can deliver something meaningful with our customers in just 3 or 6 months. And in case of data engineering and data science projects, I believe that 3 or 6 months is usually a short period of time, especially if you build something from scratch. And this requires that we introduce a number of good agile practices. For example, we start with a discovery phase that usually takes just a few days or maybe sometimes a few weeks, depending on the complexity of the project. But during this phase, we want to understand the business use case and the real goals that customer would like to achieve. And this definitely helps us to define the vision of the target solution, but also we can specify very initial backlog of tasks and the very first milestones that we could achieve. But maybe I can explain it better with a more concrete example. Because, for instance, 2 years ago, we had been working on a complex project with one of the banks. So, banks, by definition, are not the startups or scale ups that are digital native and work in very agile way where change is developed in their like business model. So banks are more enterprise companies with their own rhythm of working. And in this project, our goal was to build their ML platform in the cloud. Move actually, because before then they had been working on-premise infrastructure. And also we needed to introduce the MLOps toolkit that could support the lifecycle of their machine learning models. And then finally we had to migrate and run tens or even hundreds of their machine learning models in the cloud. And the initial idea could be to build their ML platform first and solve all necessary infrastructure, platform, security, networking challenges first, and then ingest all necessary data sets and data sources to the data lake, and then start moving their ML models there. But instead, we decided to follow more agile and more iterative approach. So we agreed that we'll first take into account just a single representative machine learning model, and then build the first version of the ML platform with all features that are necessary to support the lifecycle of this single model only, and also ingest only a few data sources that are only needed by this model. So let's assume that this was a batch model that comes from the business unit number 1. And then we simply took a second batch model from the second business unit and added just a few necessary functionalities to our ML platform and ingestion and ETL pipelines to support this model as well. And then we took the third model, and for instance, you could take the online model, not the batch one, from the other business unit, and then you could add new functionalities to our ML platform to support, for example, serving the online models or even online feature engineering. So in this agile and iterative way, we extended the functionalities of our ML platform by onboarding new models one by one, but we only added features that were required by our models, and the same about the data ingestion and ETL pipelines or about feature engineering. So in other words, in each iteration, the customer got new functionalities that they could start using immediately, and only the functionalities that were really needed based on our current priorities and based on our milestones and the end vision of the platform. And to achieve this goal, that we develop something useful in iterations, we had to introduce a number of agile ceremonies, such as stand-ups, sprints, and demos. And it was extremely useful because we could demonstrate the results of our work to the shareholder, we could collect the feedback, we could ask questions. We could also identify the risks as early as possible and try to mitigate them without as little cost as possible. And even we could change the way of our work or change the priorities, because sometimes it was needed, because in each iteration we discovered something new. And it was interesting to learn how quickly our requirements or assumptions had changed, especially given the fact that 2 years ago, not that many banks or finance companies built their ML platforms in the cloud, because those were, and I believe still are, quite innovative projects in this sector. But we managed to include changing requirements in our work. And I must also say, when I talk about introducing iterative and agile way, that the one thing that I learned is that the concern that our customers had sometimes, that they were afraid that when we follow such iterative approach, we could end up building some solutions that are good for short term, because we could quickly show the results of our work, but this solution might not be good in the long term. However, we address this concern by actually having a quite clear vision of the target solution that we initially come up with, and we adapt in each iteration, something that we want to deliver at the end of the project, and we periodically check if new functionalities or new use cases can be implemented without refactoring. And what also helps us very much is the fact that our customers are very engaged, very responsive. Very often they build solution with us. So thanks to that, the feedback loop, which is very important, this feedback loop is very short. Our customer is getting updated very often about the status of the work, and if they change some requirements or some of the assumptions are no longer valid, they know that we can handle those scenarios, and they understand why we need to make decisions to change something, and they are not afraid of such change.
That's very cool. That's really, really cool. Yeah, so many folks in your situation would be like, all right, let's do a statement of work, Here we'll
Mhm.
deliver, tranche one in like 6 months, and then whatever, and it wouldn't work. So yeah, it's great. That's excellent.
Yes, yes. This unfortunately would definitely happen if we wouldn't push for agile approach in those type of projects.
Yeah.
And this concludes our podcast episode. So thank you very much for this conversation, and thank for everyone from our audience for listening.